Alright everyone, tonight's discussion is going to be about type 2 ionic compounds. I'm sure you're wondering at this point when we're going to get to the middle part of the periodic table, also known as the transition metals. If you've noticed, we have ignored all of these metals so far. We've only been working from groups 1 and 2 metals with our type 1 compounds. That's the difference between a type 1 compound and a type 2 compound. Type 2 compounds are formed by the transition metals. The reason why we have a different classification for them is because, unfortunately for us, transition metals don't follow any rules, and they have multiple oxidation states, which we know as charges. Alright, so now we know transition metals don't behave like the others. They have multiple charges. How do we know which ones are which? Well, I'm going to give you a copy of this chart in class, and we can see here that copper, mercury, iron, cobalt, chromium, tin, and lead have multiple charges. They also have two kinds of names. They have the Latin name, such as cuprous, or copper 1 is the English name, and we use them interchangeably. The other thing I want you to notice here is that there are 3 elements in the transition metals that do not have multiple oxidation states. So on your own purple periodic table, I would like you to make sure that you mark silver as being only +1, cadmium as being only +2, and zinc as only being +2 as well. Alright, so let's get to writing formulas first. We do this because actually writing the formulas is easier than figuring out the name. So when we take a look here, we have ferric oxide. So here I gave us the Latin name. So what we have to do is come over to our list and we have to find ferric. And when we find ferric over here, we find out that ferric is iron 3 or iron +3. So that tells us that iron gets a +3 charge. Now oxide, we know comes from oxygen, which is in group 16. It has 6 valence electrons, and it needs 2 more to get its oxide, or excuse me, to get its octet. So oxide is O -2. And this we learned from our class time today. Now, we learned today that we crisscross the value of the charge for the formula writing. So we're going to bring the 3 down to the oxygen and the 2 down to the iron, and our final formula will be Fe2O3. Now, for example 2, I didn't give you the Latin name, I gave you the English name, tin 4 bromide. This makes it that much easier for us. We don't even need the chart. We can look at it, but because the Roman numeral tells us 4, we know that tin is going to be a +4 charge. Now let's say you don't remember that. When you look over here for tin 4, you'll see that tin has a +4 charge. These charges do not need to be memorized. You will always be given them. Looking at bromide, we know that bromide comes from the element bromine, which is a halogen in group 17. Group 17 elements have 7 valence electrons. From an energy standpoint, it makes more sense just to gain 1 more. So bromine forms a -1 charge. When we crisscross our values of our charges, we get a formula of SnBr4. Alright, now naming type 2 ionic compounds requires a little bit of work. We have to unpack the formula in order to figure out what charge our transition metal is. What I mean by unpacking is we have to uncrisscross. So let's take a look at our first example, Cr2O3. We have to name it. We know it's going to be a chromium oxide of some sort, but we're not sure which chromium, because when we look at our chart here, we see that chromium has 2 different charges, +2 or +3. So we're either going to have to name this chromous or chromic oxide. How do we figure that out? We have to look at the subscripts. So when we do that, we see that the oxygen has a 3. Well, where did that 3 come from? That's right. When we crisscross, that 3 came initially from the chromium. So that tells us that we're working with chromium plus 3 here. So when we look at chromium plus 3 on our chart here, we see that we have chromium 3 or chromic. So we name this chromic oxide or chromium 3 oxide. For example 2, we have PBS. Now right away we can identify PB as lead, and we can identify S as sulfur, which would then be called sulfide according to our binary rules. But which lead is it? This is where we're not sure. And we also don't know what the subscripts are because there aren't any written down. So you have to do some thinking. You have to locate sulfur on the periodic table. Okay, so when we take a look at sulfur here, we see that sulfur is right here, and it's a group 16 element. Group 16 elements have 6 valence electrons. They need 2 more. So that tells us that when we were crisscrossing this formula, sulfur had a -2 charge. Well, in order for us to only need 1 lead, what charge did the lead have to be in order to cancel out the -2? That's right, it had to be +2. So this time we have lead 2. So when we look on our little chart, we see that we can name this either plumbus sulfide with the Latin name, or we can name it the English name, lead 2 sulfide. Now you might be wondering, do you need to give me the English name or the Latin name? It depends on the directions for the problem. If there are no directions, you get to choose. I hope this helps you figure out type 2 compounds. Please give a couple a try on the worksheet number 2, which is the back side of worksheet number 1, and we'll discuss this more tomorrow in class. Have a great night.